So, while folks on Earth were busy biting their nails wondering what was going on with the US presidential elections in November 2024, what was going on in space? At the ISS, International Space Station, a small Japanese spacecraft called LignoSat came to visit. This was created by Kyoto University and a home-building company called Sumitomo Forestry. And what's the big deal with this satellite? It was made of wood. Now, that's an aberration, considering a lot of satellites are made of titanium alloys or aluminium alloys or some kind of carbon fiber or similar materials. Because you'd want something anti-fragile enough to withstand a pretty harsh environment, like space, where there's extreme temperature, radiation, meteors, and the chilling realization that it's all a vacuum. The interesting aspect of this is that if wood satellites could become a thing, it just might be a cleaner and more sustainable way to explore space. Unfortunately, while space exploration might seem cool, it could have some distressing environmental consequences. And if people are focusing on something as grandiose as space, maybe environmental sustainability's not a primary focus for them. The status quo materials might be known for being structurally durable, resistant to heat, and more. So, it's about technical performance. But, maybe, when the satellites from these metals burn up, they are said to release some metal particles that might not be too cool for the atmosphere or for the ozone layer. Plus, there's said to be a lot of space junk with about 3,000 dead satellites littering space. It's opined that if there's too much space debris, the Earth's orbit would be so overpopulated that there'd be no more future space activities. On the other hand, wood satellites, instead of releasing metal particles, might end up releasing water vapor and carbon dioxide, and if there's a vacuum, maybe the carbon dioxide wouldn't have the same environmental effects that it does on Earth. There's something called cosmic radiation that could pose risks to spacecraft, and some think that wood just might be able to absorb that radiation, unlike metals, which might create secondary radiation. So, if wood can be Captain America's shield against cosmic radiation, that might mean it could make human missions a bit more safe. Plus, wood might be a cheaper alternative to metals in terms of mining or manufacturing or refining. So, what's LignoSat looking to be and do? Made of wood, the idea is that upon re-entry, it would decompose with minimal environmental impact. It might even sound sweet, space exploration that works in harmony with Earth, not at its expense. Of course, the issue some may have with wood is, can it be as durable and resilient to deal with space, the way metallic alloys might be? For nearly a year, the Japanese team worked to determine which wood could stand the test of time and space, with a wood called Hinoki Magnolia emerging as the winner. They even did Science-Y experiments by exposing Hinoki Magnolia to solar radiation, cosmic rays, and more. And even more interesting is that the final product wouldn't need screws or glue or nails. Using traditional Japanese woodworking, precision would be used to make sure it all fits together tightly and holds in place. Now, that's impressive. Imagine using ancient techniques for something as modern as space exploration. So, what now? In December 2024, LignoSat would be deployed into space to face the brutal trials of nothingness, transitioning between the heat of direct sunlight and the cold shadow of Earth. If the satellite can endure those temperature shifts, it just might end up being the new standard for space. Of course, there'll be further analysis to see what works and what doesn't. And if the Elon Musks of the world are genuinely serious about humanity having a lunar base or a Martian colony, then human settlements in space might necessitate wood to protect people against cosmic rays. Maybe creating synthetic materials could be tougher to produce off-Earth, and even if building materials have to be transported from Earth, there are a lot of costs and logistical challenges there. This seems so futuristic that even the phrase off-Earth for human settlements might raise an eyebrow or two. But maybe, if wood still has some issues, could it be treated with some special coatings to make it more inoculated to degradation? Or could it be a complement to metals in building satellites? If this is successful and applicable, it might be of some interest to ISRO, Indian Space Research Organization, which has, built a reputation for executing successful missions on limited budgets. In 2023, Chandrayaan-3 became the first spacecraft to land near the Moon's south pole, being built and launched at a budget of about $75 million. Compare that with Russia's Luna 25, which was said to have a budget of about $200 million, or the US NASA, which may spend close to $95 billion on its Artemis moon program. India's forest and tree cover is said to be about 20% of its total geographical area. So, if wood's the new best thing, India would have a significant wood-based satellite industry. Though, places like the US, Russia, and Brazil might also leverage their forests for this purpose. This could give India's timber a new purpose and source of monetization. While India doesn't have Hinoki magnolia, could wood, like teak or sal or Indian cedar, be as durable? Of course, weight and density might be roadblocks, too. With more than 3,600 startups in the deep tech space, India is said to rank 6th in the global deep tech ecosystem. If these Indian deep tech startups want to reduce their reliance on imports, when it comes to satellite manufacturing, wood would be the way to go. That might even simplify their logistics and reduce their costs. A more strengthened supply chain for India's satellite production might be appealing. Right now, it's still somewhat of an ambition. A lot has to be examined about wood to understand what its weaknesses might be. But, if it gets to the stage where wood is an accepted source, Indian deep tech startups would still have to demonstrate how their wood satellites are different from global counterparts. Wood is not a novelty in and of itself. There might have to be innovation on top of that. So, is the future of space wood-based? Log in soon to find out.